Hello learners, and welcome to today's lesson of functions and relationships, equivalent forms. So let's start off our lesson with a did you know? Did you know that the same function can be represented in many different ways? Yes, one function can be represented verbally, in a flow diagram, in tables, by formula, or even by a number sentence. These different representations would all be equal to one function. Isn't that interesting? Let's see what our lesson has for us today. So by the end of this lesson, you should be able to determine, interpret, and justify equivalence of different descriptions of the same relationship or rule presented. These rules would be presented verbally, in a flow diagram, in tables, by formulae, and by equations. So let's look at our concept map today. Our concept map here, of course, our focus is functions and relationships. So we are going to move from verbal representation to flow diagrams. That's going to be our first concept. Then we are going to go from the flow diagrams to table representations. And then lastly, our last concept, we are going to look at from the word representations to the formulas and equations. So that's what we are going to be focusing on in today's lesson. Let's look at the pre-knowledge that we must have. So you must know how to determine the input values, output values, and the rules in flow diagrams, tables, and formulae or equations. So the first activity that we are going to practice that pre-knowledge on, we have been given a flow diagram, and in this flow diagram, so it says they determine the input values and the rule as an equation. So we are given the output values in this flow diagram. So what are we supposed to determine? We are supposed to determine the rule as an equation, or firstly, actually, we are supposed to determine the input values. Then afterwards, we are going to determine the rule as an equation. Let's look at the output values that we have been given there. Remember, those output values are the Y values. And of course, we need to find the input values that were used to find these output values. Remember, there is a relationship when it comes to functions and relationships. There is a relationship between the input values, which are the X values, with the output values, which is the answer from the input values. So the Y values are the results of us using that input value. So let's look at the rule there. Our rule there says multiply by 2. So we know that our output values have now our input values have been multiplied by 2 to get our output values. So since as well we have the output values, how are we going to find those input values? Well, if you are thinking of the multiplicative inverse of 2, then you are absolutely correct. We want to move backwards because we have the answer. We want to know what we initially started with. So our first output value is a 10. So for us to result in that 10, an input value was multiplied by 2. So what is the answer going to be when we move backwards, or when we use the multiplicative inverse of 2? Now remember, the multiplicative inverse of 2 is a half, or dividing by 2. So we are going to take that 10 and we are going to divide it by 2. So what is 10 divided by that 2? So 10 divided by 2 would be a 5. And just to make sure that we have our input value correctly, now if we take that 5 and we make it go into our rule, which is a multiply by 2, what is the answer when we say 5 multiplied by 2? Yes, you are correct. The answer is indeed a 10. Let's do the same for the other output values that we have there. We have 16 as an output value. So what is going to be the input value that resulted in an output value? Well, we are going to use that multiplicative inverse of the 2. So we are going to take 16 and we are going to divide it by 2. So 16 divided by 2, that is going to give us an 8. So 8 multiplied by 2 resulted in 16. That is correct. What about the 24? 24 is the last output value that we have been given there. So we are going to take that 24 and we are going to apply the multiplicative inverse of 2. So that is 24 divided by 2. Do you know what the answer is supposed to be? Yes, if you are thinking of 12, then you are absolutely correct, because if we say 12 multiplied by 2, that is going to give us an answer of 24. So that was the first part of our equation there. What about the second part, or sorry, the first part of our question? What about the second part of our question there? It says we need to determine the rule as an equation. Now remember, that rule or formula, it has to include the y and the x as those variables, because we are going to represent it algebraically. So we know that our output value was found by taking our input value and multiplying it by 2. And that is all that happened for us to get the output value from the input value. So that means that our rule is going to be y is equals to 2x, because of course 2x just means 2 multiplied by x. Let's move on to our next practice, our pre-knowledge practice. So here we are given a table, and that table is showing us input values, of which we can see is represented by x, and output values, which is represented by y. So what are we supposed to do in this table? We are supposed to determine the output values in the following table. Let's look at the rule that is being used there. So the rule that is being used there is y is equals to a negative 5 plus 1. So that y is equals to negative 5 plus 1, what does it mean? It means our input value was multiplied by negative 5, and then we added a 1. So we are going to use that rule to find our output values. Now the first input value that we were given there is a 2. So we are going to multiply our negative 5 plus by 2, and then we are going to plus 1. So what is negative 5 multiplied by 2? Yes, that gives us an answer of a negative 10. And when we add 1 onto that, that is going to give us an answer of a negative 9. So when the 2 is an input value, the answer there is a negative 9. So we are just going to fill that out in our table. So that is a negative 9. Then we have a 5 as an input value. So that means that our input value is going to be multiplied by a negative 5. And then we are going to add 1. So what is a negative 5 multiplied by 5? That is a negative 25. And when we add 1, that is going to leave us with a negative 24 as our answer. So when the input value is a 5, the output value is a negative 24. What about the 10? So the output value we get by multiplying the input value by negative 5 and adding 1. So we are going to multiply 10 by negative 5, which gives us a negative 50. And when we add 1, that is a negative 49. So there you have it. We have now determined our output values from this given table. The last practice question that we are going to look at, we are going to identify the variables that are representing the input values, the output values in the following equation. So we have been given an equation of y is equals to 4x plus 5. But of course, as we have seen in the previous questions, we already know which variable is representing the output value. Well, the output value is represented by the y. And what about the input value? The input value, of course, is represented by the x. So these are things that we already know and that are going to help us in our lesson today. Lastly, let's look at the words that we're going to use in this lesson. We have an equation, which is two expressions that are equal to each other. Now, for example, we have an expression of 3y plus 1, and we have another expression of 5x minus 8, and these two expressions are equal to each other, making them an equation. Then we have a formula, which is a mathematical relationship or rule expressed in symbols. An example of this is y is equals to 2x plus 3. Then we have equivalent form, which is different representations of expressions of the same value and meaning. So for example, if I have a value is added to 4 as a word sentence, that is going to be equivalent to the expression 4 plus x, because that shows that a value is added to 4, where that value is represented by x. So that is the equivalent form. Let's quickly go to an ad break and then we'll see you just now.